Alright, this is part 2 of our lesson on multiplying rational expressions. Again, I encourage you to put your pencils and pens down and just watch and learn. But the real learning takes place when you go back and try to do these problems by yourself. So watch me do the problems. I'll show you how to do them, but rather than copying along with me, go back and do the problems on your own, and then you'll remember. Alright, when you see more complicated problems like these, you should be looking for ways to factor. So obviously if there's a GCF, like you see here, 7 is a common factor, so I can factor that out, and that's going to leave x plus 5. But this will probably factor as well. Let me just cross this out because I've replaced it. This will probably factor as well. As a binomial times a binomial. X squared can only factor as x times x. When I see 40, the first thing that pops into my head is 5 times 8. You know how I'm always saying inner plus outer equals middle. Inner, I have 5x. Outer, I have 8x. I'm trying to get a middle of -3. To get a -3, I need a -8 and a +5. So +5 and -8. But I have to make sure I'm getting -40. I am. A positive times a negative is a negative. So there you go. So now I've factored this as well. Okay. Alright, so this is what we have so far. I'm just going to clean it up to make things more obvious. Alright, so at this point I have x plus 7 and I have x plus 5. Whoa. And I have x minus 8. Alright, in the denominator I have 7, and I have x plus 5, and I have x minus 8. Alright, you don't have to show this step. You could go from here, but I just thought I'd clean it up to make it that much more obvious. That what comes next is I cancel out any factors that are the same in the numerator and the denominator. Notice they're not opposites, they're the same. It's not plus 5 and minus 5. It's plus 5 and plus 5. It's x minus 8 and another x minus 8. They have to be the same, not opposites, to cancel. So this part right here is going to wind up being my final answer, but I'm just going to recopy it. So x plus 7 over 7 is the answer to number 15. But let's not forget the restrictions. X plus 5 cannot equal 0, and x minus 8 cannot equal 0. So subtracting 5 from both sides and adding 8 to both sides. Okay, so right here I see that x cannot equal -5 and x cannot equal +8. Alright, that is part of the answer, so do not leave off your restrictions. Alright, let's do the same thing again. So here we have a GCF of 3b. So if I pull out 3b, that's going to leave behind b plus 6. Okay, now in the denominator, I see I have a b plus 6. So I can cancel out the b plus 6. Alright, so that's going to leave me with 3b alright, in the numerator over b plus 8. And that's the final answer. Notice that I cannot cancel out these b's. Oh, I should have emphasized it on number 15 as well. Notice I cannot cancel out these 7's. Alright, they're connected by addition. And you can only cancel out things that are connected by multiplication, not addition or subtraction. So leave those b's alone. Leave those 7's alone. And don't forget about your restrictions. B plus 6 cannot equal 0, and b plus 8 cannot equal 0. So subtracting 6 from both sides and subtracting 8 from both sides tells us that b cannot equal negative 6 and b cannot equal negative 8. Okay, how about number 19? Okay, let's factor things. So I see a common factor here of 21x. Okay, you know what, maybe I'll factor it down here. So if I pull out 21x, okay, from these, that's going to leave behind x minus 1. Okay, and then I've still got that 6x up there, so I'm just going to put that up there. Now down here I have a common factor of 18x, so I'm going to pull that out. Alright, 18x, and that's going to leave behind x minus 1. And then I've got this 6x squared. So I've got 6x squared. Okay, so now it's time to start cleaning things up a bit. Okay, so these x minus 1's will definitely cancel out, so they're gone. Okay, these x's will cancel out, so they're gone. These 6's will cancel out as well. Okay, now I've got x over x squared. Alright, remember, x squared is x times x. Alright, so I can think of it that way, and I can go ahead and cancel out one of these x's. Okay, so this is what I have so far. Alright, I'm just cleaning things up a bit. At the moment I still have, well, the only thing in the numerator is 21, and I've got this 18 and x. Alright, but yeah, this can be simplified more. It was just getting a little messy. Both of these are divisible by 3. Alright, so I can divide both of these by 3. And I think that's going to give us the final answer. Alright, so 21 divided by 3 is 7. 18 divided by 3 is 6. And then we've still got that x. So this is the final answer for number 19. Alright, of course we have some restrictions. From these x's, these plain factors of x, we know that x cannot equal 0. So let's put that down. But also because of the x minus 1, we know that x minus 1 cannot equal 0. And adding 1 to both sides, that tells us that x cannot equal positive 1. Alright, because if x were positive 1, then I'd have 1 minus 1, and that would make 0. Can't have that. Okay, how about number 21? Okay, if I pulled out the common factor of 10, that'll leave behind v plus 6. Okay, now The v plus 6 will cancel out with this v plus 6. And v minus 7 will cancel out this v minus 7. Alright, we already replaced this. So wow, everything's canceling out except for 10. Alright, so the final answer is going to simply be 10. Interesting. But wait, we can't forget about those restrictions. By now you could probably do this in your head. You see the v plus 6, that means v cannot equal negative 6, because that would make negative 6 plus 6 would make 0. So v cannot equal negative 6. You see the negative 7, so you can probably see that v cannot equal positive 7. Alright, but if things ever get more complicated, then understand that you could look at it as v plus 6 cannot equal 0, v minus 7 cannot equal 0, and you're solving. Alright, but I encourage you to begin to do that in your head as much as possible. Let's take a look at number 23. Alright, so we've got some factoring to do. Okay, I think I will redo this problem. So, I'm going to start with this right here. Okay, that's what I'm about to factor right now. Okay, so if I factor this, x squared is x times x. 25 is 5 times 5. To make negative 10, I need a negative and a negative. And luckily, a negative times a negative is positive. Okay, in the numerator, alright, because this is like one fraction, I've still got my x minus 10. Now down here, okay, I'm just going to switch colors for a second. So I'm doing this now. But this has a GCF. So if I pull out the 10, that's going to leave behind x minus 10. Alright, 10 times 10 is 100. Okay, now let's talk about this one. Alright, this also has a GCF of 9. Okay, so if I pull out the 9, then I'm going to have 5 minus x. Okay, now you see how this is backwards? Let's do a quick side lesson on reversing factors that are written backwards. Okay, quick side lesson. Okay, let's say if I have 3 minus x. This is backwards, okay? So let's go ahead and reverse these. So if we reverse these, you know what, first of all, let me just space these out to make it a little more obvious. 3 minus x, we have a 3 and we have a negative x. Alright, that's what we're dealing with. In fact, you could think of this as a positive 3 and a negative x. So when you reverse these, what you have is you put your negative x first, and then your plus 3 second. So we have negative x plus 3. Now, we don't like our leading coefficient to be negative when we're factoring. So what we will do is we will treat this like a negative 1. Okay, so we have a negative 1x. And we'll pull out that negative 1 outside of parentheses. And we will find that we will have x minus 3. Alright, so it's like negative 1 times x minus 3. Okay, and if you think about it, this makes sense because negative 1 times x is negative 1x. And negative 1 times negative 3 is positive 3. Now, we wouldn't really put a 1 right here, so this is really just negative x minus 3. Okay? Now, look how that compares to the original problem. Alright, we have 3 minus x, and that equals negative x minus 3. Alright, so in the end, all we did was we reversed the 3 and the x, and we put a negative sign out front, right? Because it's the opposite. So let's go back and use that pattern as a shortcut that we could memorize. Okay, so for example, let's say if I have 7 minus x, how could I quickly rewrite that? Negative x minus 7. What if I have 4 minus x? Well, that's negative x minus 4. Okay, what if I have y minus x? Well, that would be negative x minus y. Okay, so this is something that you're going to want to hold in your head. So anytime you see something backwards, put a negative out front and write it in standard form. Okay, so back to business. So when we have this 5 minus x, what we can do is rewrite it as negative x minus 5. So I'm just going to do that now. Alright, so that 5 minus x will become x minus 5, and that negative, I'm really just gonna put it all the way out front. Okay, or should I put it right here? I don't know, it's difficult to know what to do. Maybe I'll leave it right here for right now. Alright, I was tempted to put it way out here, which would have been the same thing. I'll leave it right there. Okay, now, time to look for things to cancel out. Okay, so one of the x minus 5s in the numerator will cancel out this x minus 5 in the denominator. I also see we have x, we have an x minus 10 in the numerator, okay, and the denominator, so those are going to cancel out. So that's really the end of the canceling. Alright, that's going to leave in the numerator, the only thing I have is x minus 5. So I will have x minus 5. Now in the denominator, all I have is 10 times negative 9. So that's negative 90. Okay? Or I could have put the negative sign up here in the middle. Alright, that would be the same thing. Either way you want to do it. So this will be my answer to number 23. But don't forget your restrictions. X minus 10 cannot equal 0, which means that x cannot equal 10, adding 10 to both sides, and x minus 5 cannot equal 0, which means that x cannot equal 5. I'm adding 5 to both sides. So include that as part of your answer. Okay, that's sort of interesting. Okay, how about number 25? Alright, so we've got some factoring to do. Okay, I'm looking at this one right now, and I see the GCF. 8 and then V minus 7. Alright, 8 times 7 is 56. Alright, now I'm looking at this one. Okay, so looking at that, I'm thinking binomial times a binomial. V squared is V times V. 18 is either going to be 2 times 9 or 3 times 6. Now I like that one because I'm looking at the middle of 9, and I know I can get 3 plus 6 is 9, so let's go with that. So 3 times 6. Alright, inner plus outer equals middle. 3 and 6 make 9. Okay, so I just did that. Alright, now I'm looking right here. 8 times 6 is 48. Okay, so there's a GCF here, so that's 8 times 6. Sorry, it's plus. Alright, is 48. And then now I am looking right here. See how there's a V common to both? So I'm going to pull out that 8V. Okay, and that's going to leave behind V plus 3, because 8 times 3 makes 24. Alright, now I have factored everything. So now it's time to look and see what can cancel. I see these 8s can cancel. Might as well do that. Just stare me in the face. What else? I see this V plus 3. Those will cancel. Okay, and I see the V plus 6 will cancel. Alright, that's the end of the canceling. So the final answer is, the only thing left in the numerator is V minus 7. And in the denominator I have 8V. So this is the final answer. Notice that I cannot cancel these V's because this V is connected by subtraction. Alright, look for the variables. See these 3 V's? Each one of these V's will be a restriction. From this factor, V plus 6 cannot equal 0. Subtracting 6 from both sides tells us that V cannot equal negative 6. Ignore the 8, but V cannot equal 0 because of the factor of V. And of course, V plus 3 cannot equal 0. Subtracting 3 from both sides tells us that V cannot equal negative 3. Include these restrictions with your answer like this. Okay, that brings us to the last problem of the lesson. Okay, so once again, one more time. Alright, I've got the m plus 1. I'm just going to bring that down. M plus 1. Okay, now as I look at the 8m minus 80, I'm going to factor that. Remember, multiplication, just treat it like one fraction. Okay, so I'm going to do the GCF right here. So that's going to be 8 times m minus 10. 8 times 10 is 80, obviously. Now, that brings me to here. So focus your eyes right here. Again, I see a common factor. So that's 3 times m minus 5. 3 times 5 is 15. Alright, now focus your eyes on this trinomial. Alright, a trinomial like this will usually factor as a binomial times a binomial. M squared is m times m. 10 has two possibilities. First thing that comes to my mind is 2 times 5, but that won't help me make 9. So the only other possibility is 1 times 10. Okay, so just out of convenience, I'm going to put 10 times 1. Now, inner plus outer equals middle, don't you know? So inner, I have 10m right now. Outer, I have 1m. I'm trying to get negative 9, so I need a negative 10 and a positive 1. So there's my negative 10, and here's my positive 1. That does make negative 10. Negative times a positive is a negative. Alright, so now everything is factored. So let's look for what can cancel. Alright, so I see I have m plus 1 in the numerator and denominator, so they can go. And then I have m minus 10 in the numerator and denominator, so they go. Alright, that's it for the canceling. It's time to write the final answer. So that's going to leave 8 in the numerator over 3 times m minus 5. Don't forget about your restrictions. Alright, each of these m's leads to a restriction. M minus 5 cannot equal 0. That tells us that m cannot equal 5. M minus 10 cannot equal 0. Adding 10 to both sides gives us m cannot equal 10. And m plus 1 cannot equal 0. Subtracting 1 from both sides tells us that m cannot equal negative 1. And go ahead and record those restrictions this way as part of your answer. Alright, and that's the end of this lesson. I hope it was helpful to you. I will see you on the next video.